What is space junk? Since the dawn of the space age in the 1950s, humans have launched thousands of rockets and satellites into orbit. But what happens when these missions end? Unlike on Earth, there is no cleanup crew in space. Instead, abandoned satellites, spent rocket stages, and even tiny flecks of paint from spacecraft continue to orbit our planet, turning into what scientists call space junk. Currently, about 2,000 active satellites orbit Earth, but they share space with 3,000 dead ones. The problem does not stop there. Adding to the clutter are over 36,500 objects larger than 10 centimeter, which is about the size of a softball, around 1 million fragments between 1 and 10 centimeters, and a staggering 130 million pieces between 1 millimeter and 1 centimeter, currently orbiting Earth. The European Space Agency, ESA, warns this tsunami of debris is growing by 10% every year. Space is vast, but it is getting crowded. How did we create this mess? What dangers do they pose? And what can we do about it? Hi explorers, let us dive right in. Where is all this space junk? Most of the space debris is concentrated in low Earth orbit, LEO, a region stretching from 200 to 2,000 kilometers above Earth. This is the same area where critical assets like the International Space Station, ISS, Hubble Space Telescope, and over 7,000 SpaceX Starlink satellites as of February 2025 operate. Every second of our connected lives relies on these satellites. They are the backbone of our modern world, powering GPS navigation, weather forecasting, and global communications. However, the rapidly growing cloud of space debris, racing at 18,000 miles per hour, 10 times faster than a bullet, is a threat to these vital lifelines. Even a fleck of paint can crack a spacecraft window, and a 1 centimeter fragment of space debris packs the kinetic energy of a hand grenade, enough to cripple satellites. This can create a deadly chain reaction, increasing the risk of more collisions. Collisions and close calls. In 2009, a defunct Russian satellite, Cosmos 2251, obliterated Iridium-33, a U.S. communications satellite, generating over 2,000 pieces of debris that continue to threaten other satellites and the ISS today. Military anti-satellite tests, ASATs, have worsened the crisis. In 2007, China deliberately destroyed its Fengyun 1C satellite, creating over 3,500 trackable debris pieces, the largest single debris field in history. In 2008, the United States carried out Operation Burnt Frost, targeting the malfunctioning USA-193 satellite. This test resulted in 174 fragments, most of which quickly re-entered Earth's atmosphere. India's 2019 mission Shakti added over 400 fragments to the growing clutter in low Earth orbit. In 2021, Russia's destruction of Cosmos 1408, generating about 1,800 pieces of trackable debris, forced astronauts on the ISS to take shelter in emergency parts. In 2021, a piece of debris pierced the ISS Canadarm2, a robotic arm used to repair and manipulate objects outside the station. Just a few inches closer, and it could have depressurized the station, a stark reminder of our vulnerability in space. In 2024, a defunct Russian satellite, Resurs P1, broke apart, creating nearly 200 pieces of debris, forcing astronauts aboard the ISS to take shelter as a precautionary measure. The Kessler Syndrome, a point of no return. In 1978, NASA scientist Donald Kessler warned about a runaway chain reaction of space collisions, now known as the Kessler Syndrome. If debris levels continue to rise, future spacecraft may find LEO completely impassable, trapping humanity on Earth. Space debris poses serious financial and environmental challenges. A collision with even a small fragment can destroy a satellite worth hundreds of millions of dollars, disrupting global communications and causing significant economic losses. Worse yet, if the Kessler Syndrome were to occur, entire orbital regions could become too dangerous for future satellites and space missions. Regarding environmental risks, while smaller fragments burn up in the atmosphere, larger debris can withstand re-entry and impact the Earth's surface. Can we clean up space before it is too late? Scientists are racing to develop space cleanup technology, but solutions are complex and costly. Japan's electrodynamic tether, EDT, tested in 2016, uses a long conductive tether to slow down and deorbit space junk through Earth's magnetic field. In 2018, the remote debris mission, led by Surrey Space Centre at the University of Surrey in the UK, tested a giant net to capture dead satellites, successfully demonstrating its ability to ensnare and control space debris. In 2021, Astroscale's end-of-life services, ELSA-D, tested a magnetic capture system to safely collect and remove defunct satellites from orbit. In 2026, the European Space Agency's ClearSpace One is planning to use robotic arms to grab and deorbit debris, marking the first commercial attempt to actively remove a defunct satellite from orbit. However, there is no quick fix for smaller debris like paint flecks. We will have to wait until they naturally burn up when they re-enter Earth's atmosphere. Our choice: act now or lose space forever. The space economy is expected to reach $1.8 trillion by 2035. As companies like SpaceX and Amazon launch thousands of new satellites for global internet coverage, we could see 50,000 more satellites added to Earth's orbit this decade. That is a lot of new potential junk. Cleaning up is expensive and politically fraught. Without global regulations, we risk losing GPS, weather forecasts, global communications, and space exploration. Can we imagine a tomorrow without them? The solutions exist, but we need urgency, innovation, and cooperation. The sky is not the limit. It is our responsibility. Clean space, clear future. If you found this insightful, please like, share, and subscribe for more science content. Happy learning! Thank you.